Okay, 9.3. We're gonna decide if a quadrilateral is a parallelogram. Okay, last lesson we were deciding if parallelograms were rhombuses or squares or rectangles, right? Now we're gonna decide if a quadrilateral is a parallelogram. Okay. Definition of parallelogram is what?
Opposite sides are parallel.
Opposite sides are parallel, okay. Is that the only part of the parallelogram definition? I'm just learning.
That's
And
all.
equal in length, and equal in length. Okay, and equal in length. So, if we know that a parallelogram, opposite sides are parallel and equal in length, and we're trying to decide if a quadrilateral is a parallelogram, the only other option is that it would be what? What falls under quadrilateral besides parallelogram? A trapezoid. So we have quadrilateral, parallelogram, trapezoid. In parallelogram, we also have rhombus, rectangle, then we have square, right? Okay. A parallelogram, opposite sides theorem, converse. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Which basically goes to the definition, because the definition says that opposite sides are parallel and congruent. So if I know that the opposite sides are congruent, I know I have a parallelogram, okay? Parallelogram, opposite angles theorem, converse. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So, if the opposite angles are congruent, it's a parallelogram. If A and C are congruent and D and E are congruent, I have a parallelogram. If opposite sides are if opposite sides are congruent, I have a parallelogram. If opposite angles are congruent, I have a parallelogram. Okay, another theorem is a parallelogram supplementary angles theorem, converse. Because we've already talked about this. We've talked about how opposite angles add to be one, or how supplementary, yes, how consecutive angles are supplementary, or how adjacent angles are supplementary. But this is just the converse of that. If all angles in the quadrilateral are supplementary to their consecutive angles, then the quadrilateral is a parallelogram. So if A plus B equals 180, if B plus C equals 180, if C plus D equals 180, if D plus A equals 180, you have a parallelogram. Okay, so we've talked about this because this is just the converse of what we've already discussed about parallelograms. But this is how you prove that it's a parallelogram. Supplementary angles theorem. Yes, this whole lesson is just theorems. Parallel diagonals theorem, converse. If the diagonals of a quadrilateral bisect one another, then it's a parallelogram. Remember we said if you have a parallelogram and the diagonals bisect each other, they bisect them equally, right? Okay, this is the converse of them. If I have lines that are marked as bisecting each other, then I can say it's a parallelogram. Just working it backwards. So if AE is congruent to EC and DE is congruent to EB, then ABCD is a parallelogram. This is nothing new. This is just the converse of theorems we already have from Tuesday. Is that when we were actually in school, Tuesday?
Yeah.
So it's the converses of all the theorems from Tuesday, basically. No new theorems, just the converse. So instead of saying you have a parallelogram, the diagonals are bisecting each other, now I'm saying if the diagonals are bisecting each other, you know you have a parallelogram. Okay, so nothing new in this lesson. Just the converse, the opposite of what was happening originally. The last one says parallelogram and quadrilateral theorem. If one pair of sides of a quadrilateral is congruent and parallel, so if one side, like BC and AD, if they are both congruent and parallel to each other, then I know I have a parallelogram. So I don't need all information now. I can just focus on one set of sides, okay? If I know that set of sides is both parallel and congruent, then I know I have a quadrilateral, a parallelogram more specifically. But, if I don't have both pieces of those information, then I have to know that both sets of opposite sides are parallel, or both sets of opposite sides are congruent, or the diagonals bisect each other so that I can prove stuff. Okay, all of these are things that we've already talked about. They're just the converse of everything. No really new information, just converses. So you get problems like this, and it says, is this quadrilateral a parallelogram? What does x equal? Okay, so let's assume it's a parallelogram so that we can solve for x. Okay, how would I solve for x if I'm assuming this is a parallelogram? Okay.
You could do 2x plus 10,
Mm-hmm.
or equals,
Okay, 2x plus 10. So I'm gonna take this 2x plus 10, and what am I gonna do with it? If it's a parallelogram, what do you know about parallelograms? You can add it to 8x minus 30, and do what with that? Side equal to, yeah, 180, because these two, because they are adjacent or complementary, should be supplementary, okay? So I get 10x minus 20 equals 180. So I get 10x equals 200, yeah? So x would equal 20. Okay. So then, if x equals 20, I need to plug it back in and double check. If I do 8 times 20, what do you get?
8 times 20?
Yeah. 160 minus 30 is 130. So this angle would be 130. If I plug 20 in there, 20 times 2 is 40 plus 10 is 50. So it works. Okay? So that's what you're doing. So mathematically, on the homework, it should be easy. Okay? You have to recognize what rule is being applied. That's where it's going to be tricky, because you have to be able to figure out in your head what rule is being applied and go from there. Okay? So that is what this is about today.
And whatever Kayla says,
Yes.
bye.